Good morning. Today we are making our video for packet number 3. First thing we're going to take note of is Mr. Schultz accidentally put the wrong date on here. It is due on November 5th. We do not have school on the 4th, so I do not expect you to bring it in on a day we don't have school. So it is due on Tuesday, November 5th.
Oh no, it says November 6th on the
No, it says November 4th, because I have the same one you
It
have.
says due 11/6. Oh, that's 4.
That's a 4. Mr. Schultz writes messy. You'll learn that next year. Okay. First page, place the digits 2, 4, 5, and 7 in the boxes below to make the equation true. So you can only use each digit one time. You must use all 4 digits. Put them in the boxes to make it a true equation. They need to be balanced. They need to be equivalent fractions. So figure out, we're going to look at this and say, do I think it would make sense to say 75 over 42? That's not going to be equivalent because this is a proper fraction and this is improper. So I know that combination's not going to work. I'm going to keep working it around till I find the numerator and denominator that makes this a true equation, that they are equivalent fractions. There's only one set that will work. Our second page. I need to scroll up from way over here. Second page, Henry used 1/2 of his flour to make blueberry muffins and 1/2 of the remaining flour to make tofu muffins. He has 1.5 cups of flour left. How much flour did he start with? Now there is ways to do this doing the proper math, writing out equations. I learned how to use bar models and I just go to it with my word problems because it's a lot faster for me. So if I'm going to do it with the bar model, this is how much flour he has. So this is his flour. He used 1/2 of his flour, half, to make blueberry muffins. So 1/2 of it is for the blueberries. And 1/2 of the remaining flour, so this is my remaining flour. He uses 1/2 of that for the tofu muffins. He has 1.5 cups of flour left. How much flour does he start with? Well, if I know that this is 1/2 of the whole, this is the 1/2 of the 1/2, how much is going to be in this half? This is 1/2 of this section. What would be in my other section? Beckett? What would be in this section? If this is 1.5, what would this be? 1.5, right? So if I figure out how much 1.5 and 1.5 is, that's how much is going to be in this whole section. And I add those together. If you do it using the mathy math ways, you must write out the equations that you're using. Oh, Miss Vivi, when did you sneak in? You have a theology quiz too. Come on up. We need to get that done. Put it on my chair when you're finished. All right. Next page. Next page is our 5-card challenge. It needs to equal an ace. An ace is 1. There's 1 heart on it, so they need to equal 1. Next page is our pattern page. Pre-algebra must complete the nut table for the number of red blocks and total blocks. So, red blocks, there's 1 in that first figure, 1 in the second, 1 in the third, 1, 2, 3, 4, 5, 6, 7, 8 in the fourth. Total blocks, we have 1, we have 4, we have 9, and we have 16. I'm looking at the total blocks and I get a little excited because I see my favorite kind of numbers. Anybody notice anything about those total blocks? What do you think my favorite numbers are, Graham? Perfect squares. What is 1 a perfect square of? Say it, Michael. 1. Look at that. 1 is a perfect square of 1. What is 4 a perfect square of? Claire?
9.
What is 9 a perfect square of? Amala? 3. What is 16 a perfect square of? David?
4.
Oh, do you think the total blocks are going to be super easy to fill in now that we saw that pattern? Love my perfect squares. These pattern pages, a lot of times those perfect squares will pop up. Always be looking for them. Know your perfect squares. So that leaves us with having to complete the red. I needed to, for me personally, I didn't sit down and figure out what the pattern was. I figured out how many blues and how many purples, and I did there's 0 blues in that first one, then 3, then 3, then 3. I knew that reds, it goes on 3s. Purples, we had 0, we had 0, we had 5, we had 5, we were gonna have 5. If I can figure out, this would be 25, can I figure out how many blues? Alright, if there's 25 total, I subtract out my purples and reds and I'm left with the blue. And I just worked that going all the way down to figure out how many reds there were. Is there a math way to do just the reds without having to do the blues and purples? Sure there is. Me personally, I just filled in the whole table because it was easier. I went the easy route. If you can look and see how to figure out how many reds there's going to be in the 7th figure, go for it, but don't guess. Don't say, well, we went from 1 to 8 and that was a plus 7, so I'm going to add 7. That's not the right answer, I'll tell you that right now. Okay? So I just went through and I filled in the whole table, going off of what I know, and that you can figure in the one that you don't know. Takes a little bit more work, or if you want to figure out what the pattern is, you sure can. Just care that you get the right answers. All right, next page. Our perimeter and area. Remember, perimeter, you need to find the distance, the measurements for all sides, even if they're not listed, you need to find those. Then for the area, we can't find an area of a goofy shape, so we have to break it up into shapes that we do know. I broke it into rectangles, like that. Length times width, length times width, length times width. Add up your areas together to get the whole area. When we label, when we are just adding them, we're just adding meters, so our label will be meters for the answer. When we're doing the area, we are doing meters times meters, so it ends up being meters squared. So you took a little 2 as the exponent, meters squared. Next page is our net. We have been working with rectangular prisms. This time we are working with a triangular prism. So we need to imagine what that is going to look like when we cut it down and lay it flat. So we know that that base is one big rectangle. So I start with one big rectangle. And then I have one side up here and one side over there that are also big rectangles. So I've got 3 rectangles. I fold them up and it makes that triangle. Then I have my end caps. I have a triangle on one end and a triangle on the other end. Now it's not just laying them flat. You could do that, Alex. That would have worked too. Okay, it's not that my way is the only way it can look. There are other ways that people have done it. That's just the way my brain jumped to do it. I don't care where those triangles are, if they're across from each other in the middle. Alex had one triangle here and one triangle here. Actually, would that work? No, because this triangle would be going up and this triangle would be going down. So that wouldn't work. You do have to have the two triangles across from each other. It could be on any of the rectangular sections, but the triangles must be on the opposite ends of the same rectangle because they need to fold up the same way. Because our triangle isn't equilateral, so it does make a difference. Now we have to do our measurements. So we know the long line is 14. The end by the triangles is 5. Our sides of our triangles are 5s. Since this side is a 5, this side must be a 5. Since this side is a 5, this side must be a 5. Because when they fold, they must match each other. And the last thing to put in is the height. Beckett, I'm recording right now, so we can't be walking around asking questions. So our height of our triangle is 4.3. The height, I'm doing it as a dotted line, so I remember that is the height. Now the same concept for surface area as with rectangular prisms. Remember with the rectangular prism, we had to find the area of each side and then add them all together. So find the area of each side, then we're going to add them up. So the area of our rectangle, remember, is length times width, but I do have two triangles there, which is 1/2 of base times the height. Your base is that bottom, your height goes up to the top part of your triangle. So find the area of your rectangles. 3 rectangles, you should have 3. Then 2 triangles. Find those 2 areas. Remembering what your formulas are for triangles and rectangles. Then you add up all of your areas. So you should have an area for both triangles and an area for all 3 rectangles. Okay? I'm standing in your way. Can you see how that is? Did you get it off? All right, next page. This one's going to ask, it's a similar format as what we had before, but now we need to find the volume of that triangular prism. So it's going to be a different formula than what we've been using. So you need to write down the formula for a triangular prism. It is 1/2 of the base times the height times the length. Remember, this is our base, this is our height, this is our length. Then you have to find a half of it. You have to divide it by 2. 1/2 of the base times the height times the length. Then we have to write down what that calculation is. So it's going to be 1/2 times the base of 5 times the height of 4.3 times our length of 14. You do the math and you put the answer here. Because we are multiplying 3 different inches together, our answer will be inches cubed. Inches to the 3rd power for the answer. Then our pre-algebra question says the base, the width, and the height of the prism are increased by 2 inches. What is the surface area of the new figure? So think back to the previous page, surface area. If you increase everything by 2 inches, you're going to have a new surface area. So what I did was I actually wrote it on here. Said, well, okay, this is going to be 7, this is going to be 16, this is going to be 7, 7, this is 6.3, and I figured out what each of those new areas are for the triangle and the rectangle, based off of increasing everything by 2 inches. I can find my 2 ends for my triangles, 7 times 6.3 times a half. I can find out my new rectangles, 16 times 5, 16 times 7, my new measurements. There are 3 of those rectangles. Add them all together for the surface area. So you're doing the same shapes that you did on the net, but they are just 2 inches bigger for each measurement. Now our next one. Mr. Schultz loves Pascal's triangle. So we will be having different types of pages having to relate to Pascal's triangle. This page says the figure at the right is the first 11 rows, the top row is 0, of Pascal's triangle. A value is found by finding the sum of the 2 values above it. We'll do the first few rows together in class. So we're going to do it right now, the first few rows, and then you are going to complete it on your own. Okay? So, this is one piece. There's 0 above it. So what's 1 plus 0? 1. Okay, so we start off with a 1 right there. That's just how we start. 1 on the top. We've got one piece. There's nothing above it there. It's a 1. Same on the other side. It's a 1. So here, we're going to still, on that outside, above it is a 1. What's above this middle one? 2. Because there's 1 plus 1 is 2. And on this side, again, it's a 1. The 2 sides mirror each other. So when you have numbers on the left, same position on the right will be the same number. Okay? What am I going to put here? 1. So what did I put over here? 1. What is this going to be? 3. What is this going to be? 3. See how we work this out? So you can just go in and fill in 1s all down that outside. Same thing on the right side. Then you're just going to go in and you're going to say 1 plus 3. I'm going to put here. 3 plus 3, I'll put here. 3 plus 1, I'll put here. I said 1's all on the outside. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you just keep filling in, adding the 2 parts that are above it. Okay? It's just doing that simple adding. If you go too fast, you make mistakes. Always remember, if it's 1, 4, the other side's going to be 1, 4 with 6 in the middle. Okay? Same numbers. Next page. Mean, median, and mode with a twist. So, in 8th grade, Mr. Schultz has the Euclid Award. And this is a real thing. He has the Euclid Award. Rosa tried valiantly to get the Euclid Award, and she missed it by one test. She was very disappointed. So the Euclid Award is for mathematics at graduation. You average all of your test grades of the 8th grade year. Your average is at least 90% without rounding. So you have to be at 90 point something by the end of the year. So we have a student who scored an 82%, a 79%, and then they got 95%, 90%, 88%, 98%, 85%, 88%, 96%. You're going to use those scores to find the mean, median, and mode. What's the first thing we have to do with our data? Eleanor?
Line them up from least to greatest.
Line them up from least to greatest so you can find that mode of the most and the median in the middle. So line them all up. Mean, median, and mode, but this time we have a question. So we do have to put something in the answer. It says, if there is one test remaining, what is the minimum score the student, oh, I take that back. Rosa did get the Euclid. It was the Aiden Thomas Award she was going for that she missed, but she got the Euclid. Okay, sorry. Side note. Bad mom moment. Forgot what award my kid got. If there is one test remaining, what is the minimum score the student needs on the test in order to earn the Euclid? So right now there are 8 tests, right? 6 or 9. How many tests did they take? 1, 2, 3, 4, 5, 6, 7, 8, 9. They've taken 9 tests. They're going to take a 10th test. What do they have to score on that test in order to bump their average up to be 90%? Can't be 89.7. Oh, I'm going to round it up to 90% because it said no rounding. Has to be at 90% or higher. So what score do they have to get on that 10th test in order to get that Euclid Award? So you're going to have to figure out that math to figure out what score they would get, put it in to your data points, see if your mean turns out to be 90%. Keep trying till you find the answer. Our last page is the polyominoes. Figure out how you matched all of those up. And that is packet number 3. It is due November 5th. If you are watching this at home, I hope you have a wonderful day. Don't forget to like and subscribe.